Welcome to the Mad Max Fury Road to an A-star. Seriously, navigating the Cambridge IGCSE Mathematics exam can absolutely feel like driving through a desolate wasteland of tricky, trap-filled questions. But today, we are going to navigate that wasteland together and claim your grade treasure. In this explainer, we are focusing squarely on syllabus code 0580, and we are going to turn the overwhelming, anxiety-inducing process of calculating statistical measures into a lightning-fast mechanical habit, using your graphic display calculator. Now let me introduce you to two typical students we see all the time. First, there's Alex. Alex is the kind of student who overloads every exam answer with raw mathematical facts, just dumping numbers onto the page, but completely forgets to do any actual analysis. And then we have Sam. Sam rushes through everything, frantically punching buttons, and completely misses the specific requirements of the command words in the question. Sound familiar? Don't worry if it does. Today, we are going to look at their flawed answers, covered in red pen marks, and show you exactly how to completely transform your strategy so you never make those same mistakes.
Okay, picture this. You are sitting in the exam hall. The clock is ticking relentlessly, just echoing in your ears. You turn the page, and boom, you are confronted with a massive, terrifying array of numbers. The question asks you to calculate the mean, median, and mode for dozens of test scores. So, how do you do it in just seconds? Well, if you're like our student Alex, you try calculating these statistics completely manually. Alex is in there adding up every single number by hand, double-checking the arithmetic, dividing by the total, and then manually sorting a massive list to find the median. Not only is Alex wasting precious exam time, but they are leaving themselves wide open to incredibly simple, frustrating arithmetic errors. It's mathematical quicksand. On the other hand, Sam tries to rush it, misses the actual command word which asks to compare the data, and just writes down a single wrong mean. The ultimate solution to this high-pressure scenario lies entirely within your calculator's list facility. We need to build your strategy so that relying on this tool becomes total muscle memory.
Let's start level 1 of our mathematics success blueprint with some raw data. Imagine a classic Cambridge paper scenario right here. An athlete's 100-meter sprint times recorded over 10 separate races. We have 12.4, 12.7, 12.6, and so on, all the way down to a final time of 13.1 seconds. Our specific assessment objective here is to accurately calculate the mean, median, and mode for this specific set of data using nothing but the list facility of the graphic display calculator. With 10 data points, doing this by hand is annoying, but with 30, it is an absolute nightmare. So, let's look at exactly how we feed this raw sprint data into our machine securely, without making the careless rushing errors that cost Sam so many marks on the mocks.
To begin our strategy, we absolutely must get our calculators into the exact right mode. Now, depending on whether you are using a Casio or a Texas Instruments calculator, the entry point is slightly different, but the core logic is exactly the same. If you are a Casio user, you need to hit the menu button to access your main dashboard, and then carefully navigate over to the statistics mode. If you are a Texas Instruments user, you are looking for the Stat button, which is usually located right in the middle of your keypad. Pressing this button on the TI will open up a menu where you simply select Edit to access your lists. But hey, before we continue, subscribe to our YouTube channel Ace the Exams at ace_exams IGCE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's dive back into getting this setup perfect.
Once you're in, the interface is incredibly straightforward, but this is exactly where our rushing student Sam loses marks. You'll see a spreadsheet-like grid with columns labeled List 1, List 2, List 3, and so on. You simply enter your raw sprint times directly into List 1. You type 12.4, lock it in. Then type 12.7, lock it in, moving systematically down the column. This vertical list layout is brilliant because it allows you to easily scan up and down using your directional pad. You must double-check that you haven't mistyped a decimal point. Sam once typed 127 seconds instead of 12.7. That one missing dot ruined the entire calculation. Always do a quick visual scan of your inputted data. It's a non-negotiable step in our system.
The physical action of entering the data needs to become complete muscle memory for you. After typing each number on the keypad, firmly press the EXE or Execute button on a Casio or the Enter button on a Texas Instruments calculator. This action confirms the data entry and automatically moves your cursor down to the exact next empty row in List 1. It's a repetitive, rhythmic process. Type, execute, type, execute. Within 15 seconds, all 10 of our athletes' sprint times are safely digitized and stored within the GDC's memory, fully ready to be manipulated. This is the foundation of our strategy. By letting the calculator hold the data, you free up your brain's working memory to actually decode the command words of the question, rather than just drowning in basic arithmetic.
Let's move to the next step and witness the real transformation. We have our data. Now we must command the calculator on what to do with it. We need to calculate what are called one-var stats, which stands for one variable statistics. We only have one variable here, the sprint time itself. On a Casio, you'll hit the Calc button, then one-var, making absolutely sure your setup specifies that your X list is looking at list 1, and your frequency is set to the number 1, because each time was recorded just once. On a Texas Instruments, you press Stat, scroll right to the Calc menu, and select the very first option, one-var stats. Again, you confirm that your list is set to L1. It's like giving your calculator a highly specific map to find the treasure.
And this right here brilliantly illustrates the true power of the GDC. Watch as those red pen marks of failure transform into green check marks of success. The exact moment you hit calculate, in a fraction of a second, the screen spits out all your necessary statistical measures in one comprehensive list. Instantly, we see that the mean sprint time is 12.6 seconds. Think about the manual labor we just bypassed for Alex. No adding up all 10 decimals to get 126. No dividing by 10. The calculator does all the heavy lifting, completely eliminating arithmetic fatigue. This allows you to focus all your mental energy on actually analyzing the results and perfectly executing the requirements of the Cambridge mark scheme.
So the crucial point here is knowing exactly how to read this output screen by deeply understanding these specific mathematical shorthand symbols. Remember, decoding command words and symbols is rule number 1 of our mathematics success blueprint. The calculator won't explicitly spell out mean or median for you every single time. You have to know the code. The symbol X with a bar over it, literally called X bar, always represents the mean. The letter N stands for the total number of data items you entered. In our sprint example, N equals 10. If you scroll down the results screen, you will find MED, which is your median value, the exact mathematical middle of your sorted data. And finally, MOD stands for the modal value, which is simply the number that appears most frequently in your list. However, I have a massive, absolutely vital warning for our Texas Instruments users straight from our source material. Pay close attention. If you are using specifically the TI-84 plus CET model, your calculator does not display the modal value on this output screen. While Casio users will see MOD listed super clearly, TI-84 plus CET users will have to do a little bit of manual detective work. You will need to either scan your original raw data or look at a sorted version of your list to spot the most frequent number yourself. It's a small, slightly annoying quirk, but knowing your specific machine's limitations before walking into the exam hall is an absolutely critical part of your overall exam strategy.
Let's level up our strategy. Raw lists like List 1 are absolutely great for 10 simple athlete sprints. But what happens when the scope of our data collection explodes? How do we handle situations where we have a massive amount of collected data already grouped and presented to us in a frequency table? Entering hundreds of individual numbers in a single endless vertical list would be a total nightmare. Stop scrolling, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get back to conquering these massive frequency tables.
Welcome to Act 4, our interactive workshop. Look at this complex mathematics data source on screen. I'm putting 60 seconds on the visual countdown timer right now for Challenge 1 Data Scan. What is the core trend here? This is a frequency table showing the exact number of students across 30 different maths classes. We have 4 classes with 27 students, 6 classes with 28 students, 9 classes with 29 students, and so on. If you tried to use our Level 1 method, you would have to type the number 27 4 times, the number 28 6 times, and the number 29 9 times straight down into List 1. That is inefficient, incredibly frustrating, and a massive trap for exam anxiety. Time's up on the scan. The core trend is that the data is heavily grouped around 29 and 30. We need a better way to input this.
For Challenge 2, let's find the flaw. Instead of that messy manual entry, we adapt our strategy and use 2 columns simultaneously. It's wonderfully elegant. You input your primary data variable, in this case the number of students per class, straight down into List 1. Then, you move your cursor over to the right and enter their corresponding frequencies into list 2, exactly next to them. So what's the flaw students make? They forget the setup. When you navigate to your 1var stats calculation screen, you must make one crucial game-changing alteration. You must tell the calculator that your frequencies are no longer 1. You must manually change the freq list or frequency setting to point directly to list 2. Without this, the calculator assumes every class size only happened once. With it set correctly, the calculator mathematically maps list 1 to list 2 flawlessly.
Let's lock this knowledge in with Challenge 3, speed writing. You have 30 seconds on the timer to practice this exact same two-list technique. Look at this board game data. A player rolls a dice multiple times. The number 1 is rolled 3 times. The number 2 is rolled 8 times, all the way up to the number 6 being rolled 7 times. Think about the PL paragraph you could write about this. Put the dice numbers 1 through 6 into list 1. Put the frequencies into list 2. Run your one-variable statistics, making absolutely sure your freq list is targeting list 2. Boom, you instantly have the mean, median, and mode of all these dice rolls without breaking a sweat. It is entirely about giving the machine the right instructions so you can focus on the analysis.
Level 3, the boss fight. Comparing complex data sets using the GDC. We have arrived at the final stage. The true power of organizing your data into lists is the ability to analyze and compare two entirely different sets of data simultaneously. Let's look at the complex data for this comparison. Here we have a class of 30 students who took two completely different maths tests. For test A, look closely at the spread of the data. The possible scores range from 1 to 10, and we have students scoring at almost every single level. 3 students scored a 1, 8 students scored a 6, and 2 students managed a perfect 10. The data is scattered widely across the entire board. This is where our student Alex usually panics, dumping all these numbers into a paragraph without actually comparing anything.
But now, compare that wide spread to the exact same 30 students taking test B. The visual shape of this data is drastically, wildly different. 4 students scored a 1, 1 single student scored a 2, and then just look at score number 6. There is a massive towering spike. 24 students out of 30 scored exactly a 6. Nobody scored a 3, 4, 5, 7, 8, or 9, just a giant cluster right at 6, and a single student getting a 10. Just looking at the table tells a dramatic story, but in a Cambridge exam, visual stories don't earn marks. We need the exact, hard statistics to prove our point to the examiner.
So we put our ultimate dual list strategy to work. First, we enter the test A scores into list 1 and their frequencies into list 2. We run the 1var stats and write down the mean, median, and mode for test A on our scratch paper. Then we either clear our lists, or if you want to be a real exam power user, you simply move over to list 3 for the test B scores and list 4 for the test B frequencies. Run the 1var stats again, this time changing your setup so X list is list 3 and freq list is list 4. This is where our time management matrix shines. By running our procedure on both sets individually via the GDC, we rapidly extract hard, comparable numbers in a fraction of the time it would take to do it manually.
Now, once you have those exact statistics sitting right in front of you, you are fully equipped to answer the real analytical question. Which test did the class find easiest, and give reasons for your answer? This is where we apply the PEAL framework: point, evidence, explanation, link. Point: Test B was easier. Evidence: the mode and median for Test B are both exactly 6, pulled up by that huge spike, compared to the lower median of Test A. Explanation: because 24 out of 30 students achieved that solid score of 6, the overall performance cluster is higher than the scattered, lower scores of Test A. Link: therefore, the data clearly proves the class found Test B easier to navigate. The GDC just did all the heavy lifting, you just applied the logic and secured maximum marks.
By mastering these simple list and frequency functions on your graphic display calculator, what used to be a terrifying wall of numbers becomes an easy, guaranteed win on your exam. You transform from someone frantically crunching numbers like Alex or rushing and misreading command words like Sam into a cool, calm analyst. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to Ace the Exams IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.